Hello, Trig students. This video here, the purpose of this video is going to be kind of a summary to help you kind of get ready for the unit test for graphing trig functions. But we're just going to talk about graphing. I'm going to go into more detail about the constructing part as well. And this is just a good video for you to kind of watch. We'll call it our unit review video. This is a good video for you to watch before you take the unit exam. So I'm going to be looking at two different things here, really, mainly, and then I'll also discuss some other just general. At the very end, I'll discuss some general information about the test real quick. But basically, what I'm looking at, I'm going to look at two different things with you. I'm going to look at graphing trig functions using the widget on Khan Academy and discuss that kind of in detail. And then I'm also going to look at constructing sinusoidal functions on Khan Academy and how to do that also kind of in detail. To do this, I'm also going to be using a PowerPoint. And I am using PowerPoint this time, not Google Slides, because there are certain things that PowerPoint allows me to do. I'm keeping the outlines to these, by the way, pretty basic. I know I could get kind of creative with the layouts and designs and all those things, but I'm just trying to put everything together and get it out to y'all so quick. I'm not taking time to do all the fancy stuff. So, but this is kind of a short little PowerPoint here about this. Hopefully this will help clear up any kind of misconceptions you have before you take the test. So, first of all, the general form of a trig function. Let's discuss that real quick. It is y equals a times the trig of b parentheses x minus c, all closed in parentheses there, plus d. The amplitude of a sine or cosine function is the absolute value of a. Sine and cosine are the only functions, by the way, that are going to have amplitude. We really didn't get to talk about trig tangent functions. That's something that we'll have to maybe do once we are back together face to face, or I don't know, we'll figure it out. So the period of a sine or cosine function is 2 pi divided by b. That is the period for sine and cosine. Went backwards, sorry. The phase shift or horizontal shift. Phase shift is just a horizontal shift. You're taking the whole function and shifting it left or right, whichever direction. And I know I did that backwards for you all. But anyways, the phase shift is c. If c is greater than 0, then it is shifted c units to the right, whereas c is less than 0, it's shifted c units to the left. Now, that may sound a bit different than something I've said before, but I promise you it's not. Look at your general form here. This is one thing that I'll also mention again later in the PowerPoint, but notice it's x minus c. If c is positive, then it's going to be x minus a number, minus like 5. Let's say c is a positive 5. Then that equation will have x minus 5 right there. That means you moved 5 units to the right. Okay, 5 units to the right. Excuse me. Try to make some of my hands. All right, so if I moved it 5 units to the right. Now, if c was negative, if c is less than 0, let's say c was a negative 5 or negative 3. Let's say it's a negative 3. Then in this equation right here, if you follow my cursor, would be x minus a negative 3. Minus a negative 3 is the same thing as what? Adding 3, right? So that would really just be x plus 3. Inside the parentheses here, the algebra, what it would look like, it'd be x plus 3. So with it being plus on the inside there, that means we're really going to the left. Okay? And that's kind of why. And I hope maybe for those that were a little bit confused about that, I hope maybe this helps in clearing that up. The vertical shift is D. The midline is the equation, is basically the line with the equation y equals D. That's where the midline is going to be. And on your test, you'll have questions, guys, where you're literally asked, hey, what's the amplitude? Here's an equation. What's the amplitude? All I care about is the A value. Take the absolute value of it. Even if it's negative, just make it positive. Take the absolute value of it, type that in there, boom, got the right answer, done. You got that question right. You're all going to have one of those questions. You're going to have one question on the test that's that. You're going to have one question on the test that says, hey, what is the midline of this equation? That's the D value. You just look down here, find what D is. Y equals whatever that D number is. If it's a minus whatever, then it'll be negative. That's okay. Y equals that. Type that in. Done. Moved on. Next question. Those are two easy questions that everyone should get right on the test. You'll also have a question about the period. Pick out what B is, take 2 pi divided by B, simplify that if it needs to be simplified. Answer, done. That's 3 questions that everybody should be able to get right. On the test, you have 9 questions on the test, and 7 of them are going to be graded. You have to get, I'm going to let you miss 2 without penalty. So you already are almost halfway to a 100 just by those 3 questions. So this is the general form of a trig function. I'm going to keep referring back to it. I'm going to keep referring back to A, B, C, and D throughout this PowerPoint. And I'll put this PowerPoint also on Google Classroom as always. So let me move me up here. We're graphing sinusoidal functions with the widget on Khan Academy. So example, let's say we had this example, and I did pull this one off. You might have had this on your exercises. I actually pulled this equation off of Khan Academy. Y equals 3 cosine of 2x plus 6 pi all plus 4. 2x plus 6 pi is on the inside and in the parentheses. That's what we're taking the cosine of. So first, take care of any vertical shift the function might have. And this is literally telling you how to graph this. So on the widget, you have 2 points. You have 2 points. They're green little dots. You can move them up, down, left, right, whatever. Move them around. You have some limits on how you can move them side to side. Sometimes because you can't have them at the same value. Okay, but you can move it left to right. You can move them all over. So first, you want to take care of any vertical shift that the function might have. You want to identify the midline. So for this example, the above example, the vertical shift's up 4. The midline is y equals 4. So you would move, I would take both green points, and one of them is going to be higher than the other one or lower than the other one. Okay, they're not going to be at the same y value. But I'd take both of them and I'd shift them up 4. Eat one at a time. I'd shift them up 4. Do one, stop, don't even look at that point, look at the other one, move it up 4. You should have a picture that looks exactly like what you had before, but everything's been shifted up 4. Next, you want to identify the amplitude. So this will help determine the maximum and the minimum values of the function. So you look for the A value. And in other words, the maximum value is going to be A units above the line y equals D, and the minimum is going to be A units below y equals D. So the above example has an amplitude of 3. Amplitude's 3. That's the A value right here, 3. So I'm going to go 3 up and down, but I'm starting at 4. So I'm going to go up 3 from 4. I get 7. That's going to be the maximum. And the minimum will be down 3 from 4, which is 1. So this thing's going to go between 1 and 7. Okay. So next what you'll do is you will, to graph a sine function. So this is going to be the difference between graphing sine and graphing cosine. Okay, this is what I'm talking about here. These are the differences, because I had a question about what's the difference between those two, and that's a great question. To graph a sine function, the starting point will be on the midline. Sine starts on the midline, okay? The next point will either be a maximum or a minimum. You only have, for your points, the important points that you have on a sinusoidal function, and by the way, a sinusoidal function, that's how you say that word up there if you were wondering about that. All that means is a sine or a cosine function. Those two functions. Group them together, you get sinusoidal. Okay, it's a fancy word. All right, but to graph a sine, you only have one of 2 options, because all the points that you have are either midline points or their maximums or their minimums. Okay, maximums, minimums. That's one option, maximums, minimums. The other option is midline points. Those are your only 2 options. So if your starting point, and I put this later in a slide and I should have put it here. The starting point, I'm talking about the point to the furthest to the left, because we go left to right like we read. So the starting point will be on the midline if it's a sine function. The next point will be a maximum if A is greater than 0, or a minimum if A is less than 0. Okay, so you look at what A is, the sine of it. This case, A is 3, so it's going to be the next point will be a maximum. To graph a cosine function, the starting point will be on the maximum if a is greater than 0, and it'll be on the minimum if a is less than 0. So this is a cosine function anyway, so we forget what I just said. Forget what I said right before. So to graph a cosine function, the starting point, this case, the starting point, since this is a cosine function, it'll be on the maximum value if a is greater than 0, or minimum value if a is less than 0. A is greater than 0, so this is going to be on the maximum value. The next point will be at the midline. So you either start at a midline and you go to a max or min, or you start at a max and a min and you go to a midline. That's your options. It's pretty simple. It's two options, sine or cosine. So this case, this above example is obviously a cosine function. So we want to adjust the starting point accordingly using the criteria above. So basically, since a is positive, it's a positive 3, we're going to put the starting point at 7. It's going to start at that maximum value of 7. I also will say this about the widget. Sometimes it's helpful to switch your points. If you move the left point further right past the other point, you'll switch your points. And it's sometimes helpful with graphing cosine to do that. And then you basically switch your points, and now your left point, your new left point, which was your right point, but your new left point will be your starting point. Move it to where the maximum is at 7. Okay? Move it to where it's at 7. The next point will be the midline. That'll be at y equals 4. So put it at 4. We moved everything up 4. Now we're going to move the left point, which we might switch them first, but then you're going to move the new left point up to 7, and the next point's going to be at y equals 4. Okay? All right. Don't worry about where they are in terms of x just yet. Amplitude and midline, which is basically your vertical shift, they all have to do with y. It's all about y. Okay? This totally changes when we talk about the other two features of a trig function, of a sinusoidal function. Okay, when we talk about period and we talk about phase shifting, now we're going to talk about x. So now we want to determine the phase shift, and in what the phase shift is and in which direction. If b is not factored out on the inside, you must factor it out. Okay? Once you factor that out, we can see that. So see this function right here, b is not factored out. The 2 has not been factored out. So we're going to factor that out. We're going to factor 2 out of that. So we factor a 2 out, we have x plus 3 pi on the inside right there, because 2 times 3 pi is 6 pi. You might have to do that work off to the side. I did an example earlier. Let's see if I can find it, where it wasn't so pretty. This is another example. So it started with pi. This is what was on the inside. I didn't put all the other extra stuff out there, but you had to factor, you had pi over 2x minus pi. You had to factor a pi over 2 out. So I kind of had off to the side over here, I kind of did a little bit of work to figure out. I know pi over 2 times something. I just made it z. That was just a random variable I picked. I know pi over 2 times something has to equal negative pi. So I figured out by solving for that something, the z, I figured out that it had to be negative 2. So it factored as pi over 2 times x minus 2. Always double check yourself and make sure if I distribute that back into here that I get back to what I started with. And do the same thing here. If I distribute 2 into this, I get 2x, and 2 times 3 pi is 6 pi. So yes, check, done. So the phase shift for this would be 3 units because it's a plus 3 pi. That means that c has to be negative because remember your general form is minus x minus c. So if x minus c is on the inside there, in order for me to get a plus something, I had to have a negative c value. So I'm going to move 3 units to the left. Remember, 3 pi units to the left. 3 pi units to the left. So this thing's going to start at 3 pi to the left. Okay. Remember, default, it starts at 0. Your default point is 0. Okay. Just like your default midline and y is 0, your default starting point in terms of x is 0 also. So this has been moved 3 pi units to the left. So negative 3 pi, in other words. So you want to move both the starting point and the next point according to the phase shift. So my starting point, remember the y coordinate of it is 7. We already determined that. So now I'm going to be back 3 pi to the left in terms of x. So I'm going to be at a negative 3 pi comma 7. And the next point will be on the midline for now. Just leave it on the midline, leave it where it's at. We're going to determine where to move it at. That's where the period's going to come into play. So it's easiest to take care of your phase shift first before you take care of the period. Just like it also was kind of, and it's kind of backwards the way you might think you wanted to do it. But it was backwards for the other two as well, because we did the midline, which is the very last thing in the equation. We did it first before we did the amplitude. Okay, graphing can be a little weird. All right, so now same example here. I keep carrying this example over in the problem. Now I have left the 2 factored out now so that you can see that. I wrote it in that form instead of writing it in the original form. Now determine the period. That'll be 2 pi divided by b. So for the above example, that would be 2 pi divided by 2. B is the value right here in front that's been factored out. That's the 2. So 2 pi divided by 2, which is pi. This is the distance between the curve. This is the distance before the curve will repeat itself. The distance from your starting point to your next point is always 1/4 the period. Okay, from your starting point to your next point, it's always 1/4 of that period. You got 2 consecutive points. That means a maximum and a minimum and a midline point in either order. Okay, the order will change depending on whether you're talking about sine or cosine. But in either order, it's 1/4 of the distance. So if the period is pi, 1/4 of that distance would be pi over 4. So I need to take my starting point of negative 3 pi. I need to add pi over 4, and I get a negative 11 pi over 4. And on some of these widget problems, you do have to move the points in between the values. Pay really close attention to the scale. Pay very close attention to the scale of the graph. So like for this example, I know that from looking at it the way that it was on Khan Academy, every 2 blocks left and right was pi distance. So 1 block was a half of a pi, and halfway in between, and you can move the points to be halfway, a half of a unit, or half of a little box, half of a grid box on your graph. You can move it to be half of that. Half of that would be 1/4. So you got to be really careful with that and go negative 11 pi over 4. It also may be helpful to actually figure out what negative 11 over 4 is as a decimal. If you plug that in as a decimal, it's negative 2.75. So I'm going to go back 2, and I'm going to go 3/4 the distance to a negative 3, in other words. I'm going to go 0.75. 0.75 is 3/4. So I'm going to, between negative 2 and negative 3, I'm 3/4 the distance towards negative 3. Okay, hopefully that makes sense. So the next point will be at a negative 11 pi over 4, comma 4. Remember the midline, it's at the midline because we're talking about a cosine function. So the y coordinate, we already determined the y coordinate. If you go back and go back a slide or two, you'll see that the y coordinate was at 4. Move the points accordingly, and you should have the correct graph, and you're able to hit check answer. Okay? Hopefully this has helped. I know it's a little confusing. I know it can be tough. Take it one thing at a time. Don't look at it as the whole. Okay? One thing at a time. It's not so bad when you break it down. All right. Now let's talk about constructing for a minute. We'll go through the slides here, and then I'll go look at an example, and I'll walk you through that example. So to determine whether to write a sine or cosine function, you need to consider the starting point. That's the furthest left point. So here's where I put it, furthest left point. That's what I mean when I say starting point. If it's at a midline, you're going to write a sine function. If it's at a maximum or a minimum, you're going to write a cosine function. So that's going to determine whether you use sine or cosine. Okay? Now, next you're going to determine your vertical shift. It is where the midline is. That value will be D. Okay, it's easiest to do this in the same order that you did graphing to do the writing. However, the difficulty on each little part is a little bit different this time. But you do it in the same order that we did with graphing. We start with the vertical shift first, then we do the amplitude, then we do the period, then we do the period, and then we finally end with the phase shift. You could do the period and the phase shift either whatever order. So let's go through this. Vertical shift, you'll determine the value of D. Next, you'll find the amplitude, which is a measurement in the y direction. Okay. Now, some of these, I know it gives you your starting point is the maximum or your minimum, and your next point's the opposite. If your starting point's a maximum, the next point's a minimum. You'll have to figure out where halfway in between that is to get your midline. And then you'll have to figure out the y difference, the difference in the y coordinates, to figure out how far is the maximum from that midline. Okay, because that's going to give you your amplitude. You find the difference between the y value of your maximum or minimum and the midline. This will determine A. Remember, A is positive or negative. Remember, when A is positive or negative, see slide 4. That goes back to where I talked about A being positive or negative. You go back and look at slide 4, you'll see what I mean. All right. Determine the period. This is a measurement in the x direction. So amplitude and vertical shift, where the midline is, what all that all has to do with y. Now period and phase shift all have to do with x. Okay, so on these you're given coordinates. That determines what coordinates you're using. The distance between the x value of the maximum point and the x value of the next adjacent or an adjacent point on the midline is a fourth of the period. That's what I was talking about a minute ago, how we figured out where that next point was going to be when we were graphing. It's a fourth of that distance. You go from a maximum or I could say even a minimum there, to the adjacent point on the midline, it's a fourth of the period. The difference in the x coordinates. So once we figure out what the period is, once we figure out that distance, we're going to multiply it by 4 to get the period. Because if that distance is a fourth of the period, we multiply that distance by 4 to get the period. All right. The distance between the x value of a maximum point and the x value of an adjacent minimum point is half of the period. So that's like what I'm telling you. They sometimes give you a maximum. They skip the midline point and jump straight to the minimum. Okay, they jump straight to a minimum point over here. Okay, maybe you need to reverse that. There we go. They jump straight from a maximum point straight over here to a minimum point, and they skip the midline point, which is somewhere in the middle right here. Okay, that distance, if you think about it, the period if you start with the maximum point, if you go to the next maximum point on the graph, that distance is the whole period. So if you're going from the maximum to the minimum is going to occur halfway between the two maximums. Okay, hopefully that makes sense. It's going to occur somewhere halfway in between, so that's half the distance, half of the period. That distance is half the period. The distance from a maximum to an adjacent minimum is half the period. And you can reverse those if it's a minimum, your starting point's a minimum and the next point's a maximum. You can totally reverse what I just said right there. Remember, though, the period, this is the most important part. I messed this up one time, and I won't forget it now because I messed it up, and it made me mad. But remember, the period is 2 pi divided by b. So you will have to solve for b. You'll have to set 2 pi divided by b equal to that period and solve for b to figure out what b is to plug in the equation. Finally, you determine the phase shift. Just look at the starting point's x value, the x coordinate of the starting point, wherever it's at. Default, it should be at 0. And if it's at 0, there's not a phase shift. C would be 0. But whatever the value is of that starting point, whatever the x coordinate of that starting point is, that's your C value. The phase shift is really easy to take care of with constructing. It's way harder to take care of with graphing. So period was way easier to take care of with graphing, but it's a little bit harder to do with constructing. So you trade off there. Okay, hopefully that makes sense. Plug A, B, C, and D, all of them into this function. Remember, of course, to use SIN for sine or COS for cosine in place of TRIG. You plug all that in, boom, you plug in your equation into the computer, into Con, and you get the right answer. So let's just walk through one example of that just to make sure that we're all okay on that. So we're looking at this example right here. We're given the point that it intersects the midline is 0, -2, and it has a minimum point at 3 pi over 2, comma, -7. So my starting point is this point because it's the furthest to the left. I can tell because 3 pi over 2 is obviously more than 0. So that's to the right of 0. So the left point is this one. So I'm starting at a midline. Starting at a midline, what am I going to use? Sine or cosine? I'm going to use sine. So it starts at a midline. So we figure out what the vertical shift is first. Look at the y coordinate of your starting point right there, -2. That's going to be it. It's going to be down 2. Instead of it being at 0, it's at -2. That means I've been shifted everything down 2. So I'm going to put a -2 right there. Now, this is backwards. Like I'm typing this whole thing in backwards. So that's the very last thing I put on the equation. So I'm going to hit the back arrow key or back arrow, whatever. I'm going to move my cursor back over here to the furthest to the left inside this answer box, and I'm going to figure out the other stuff. So next we got to figure out the amplitude. We'll look at the y coordinates. Between your minimum and your midline, -7 and -2, what is the difference between those? And if you subtract them, you get 5. Okay, this is starting at a midline, and it's going to go to 5. We're using a sine function. We're going to have to plug some stuff in. So I would type in SIN for sine. I'd open parentheses here, and I'm ready to type stuff inside the parentheses. And notice I put the -2 on the outside of the parentheses right there. Now it's having trouble recognizing it right now. That's okay. You're not done yet. So the 5, we gotta make sure it's positive or negative. Notice where I started. I started at a midline and I went to a minimum. You look at slide 4 for sine, that means that this is negative. A is negative. Okay? Because normally sine starts at the midline and the next point is up at the maximum. But because I'm going down to the minimum, I'm doing the opposite. It's negative. So A is negative. All right. Next, we're going to figure out where what our period is. So that distance there from 0 to 3 pi over 2 is 3 pi over 2. This can be the hardest part, really, of constructing. So 3 pi over 2 is going to be a fourth. That's going to be 1/4 of the period. Okay, so 1/4 of the period is equal to 3 pi over 2. That's the difference between these 2 points right here. In the x, we're looking at x coordinates. So hopefully that makes sense. 1/4 of the period is equal to 3 pi over 2. So if I solve that for the period, I would multiply both sides by 4. And I would get the period is equal to 3 pi over 2 times 4. Okay, let me write this on a different piece of paper real quick so you're not seeing the other side of my paper. I used the different side of the same paper. Let me recopy this real quick for us. Multiply both sides by 4. 1/4 times 4 is 1. So I get 1 times the period, or the period equals 3 pi over 2 times 4. So now I'm going to simplify that. That's going to give me 12 pi over 2, which is 6 pi. Three times 4 is 12. So 3 pi times 4 is 12 pi. 12 pi over 2, which is 6 pi. So the period is 6 pi. Okay? That's what 2 pi divided by b is. So I need to set 2 pi divided by b. This is the most important part where you can mess it up. You need to set 2 pi divided by b equal to 6 pi. And we got to solve that for b. So we multiply both sides by b. We get 2 pi is equal to 6 pi times b. And then we divide by 6 pi. and we're going to get B is equal to 1/3. Okay, hopefully that makes sense. So the B value is 1/3. So I'm going to type a 1/3 in here. Notice it gives you the option of a fraction right here. So you're going to hit 1/3, and we're going to put X right there. Now, normally we were going to open up the parentheses right there too, because we could have a phase shift. Now this one, forgive me, this one has the, if we look for the phase shift here, we look at the starting point. We look at the X coordinate. The X coordinate of your starting point is 0. So this one's really not been phase shifted at all. So your C value would be 0. So you'd have X minus 0 on the inside there, which is just X. So this is the right answer. We can check it. And it tells us it's the right answer. And you're done. I hope this has been helpful. I hope that you've had a good experience with this. Hopefully this video will help you review for the test. Now, a couple things about the test. It's 9 questions. I'm only going to grade 7. I'm going to let you miss 2 questions. If you read my Google Classroom post, I'm going to let you miss 2 questions, no penalty. That will probably take care of the word problems. I understand the word problems are a little tougher. If we were in class, I really don't emphasize the applications as much. I just don't have time to emphasize them as much. I wish we did. They're really good applications. Hopefully, just by going through and doing the exercises, though, you realize, wow, there's so many places that this has applications in. You've already seen things with physics, Newton's, forces. No, I'm causing some anxiety by saying those words. But you've seen things with physics, you've seen things with temperature, and all these other things. There's all sorts of phenomenon in the nature that can be modeled with sine and cosine functions. And that's the main thing I want you to get from that, even if you don't get the problems necessarily right. So you get to miss 2 questions, no penalty. So 7 questions. This will not go out of 100 points because it's only 7 questions long. So just be mindful of that. It'll be okay if you miss. It's not going to be the end of the world. It's not going to go out of 100 points. Okay. Try your best. Like I said, 3 questions easily everybody can get is what's the mirror? Here's an equation. What's the midline? Here's an equation. What's the period? Here's an equation. What's the amplitude? Those are 3 things that you should easily get by now, as long as you've been paying attention to the assignments. Easy. You'll have a couple graphing problems, probably 1 sine and 1 cosine function. If you know how to work the widget and you figured that out, that's 5 questions there total now. Added with the other 3, that's 5 questions. And I'm only grading this out of 7, so you're already on a way good track to doing well on this test. Okay, I hope this makes you feel better about it. Just let me know if you have any questions. I hope this video has been helpful. You all just like I said, just let me know if you have questions. The test is due April 6th, which is next Monday. That's the Monday of spring break. I wanted to make it due then because I want you to take next week off, rest, spend some time with your family. Please do social distancing, though. Let's not jeopardize all the things that we've done so far. I want this to hurry up and be over. I want you back in my classroom, and I want to see you again. So please practice your social distancing. Please do what you need to do, but stay at home as much as you can and just be with your family. Spend some time with your family. This is the good time to do that. Go outside, stretch, walk, do some things, but stay away from people, basically, as much as possible. Thank you all. Have good luck on the test. I'm sure you'll do fine. Just look over your notes. Look over this. You can use your notes on the test even, because I'm not there to police that. And as always, if you need anything, let me know.